Welcome to the class of Control System 1 with Priyanjali Mukherjee, Assistant Professor of Electrical Engineering Department of Narula Institute of Technology. In this class, we'll consider the signal flow graph. And in this lecture, it contains the signal flow graph, the signal flow graph with the block diagram reduction, the signal flow graph terminologies, construction of signal flow graph, the Mason's gain formula, and reduction of transfer function using the Mason's gain formula. So first consider the signal flow graph. It is another graphical representation of the control system, and it consists of a network graph in which the nodes represent the system variables. The nodes are connected by the directed branch, and the directed branches represent the blocks of the system. That means in signal flow graph, in one, which variables are represented by the nodes of the graph. And it is commonly used to represent the signal flow in a physical system and its controller. And in block diagram reduction technique, we have used that the transfer function, summing points, takeoff points, which all are eliminated by the branch and nodes in this signal flow graph. And it depicts the flow of signal from one point of a system to another and groups the interrelationship among the signals. So this is a comparison with the block diagram reduction, that is both are applicable for linear time invariant system, and in block diagram reduction each element is represented by a block, whereas in signal flow graph each element is represented by the nodes. And the summing point and takeoff points, which are separate in case of block diagram, whereas both of these are eliminated by the nodes and branches in case of signal flow graph. In block diagram, there is no concept of self loop, whereas it exists in the signal flow graph. And the signal flow graph is a set of algebraic relations. Thus, we can find out the signal flow graph for a specified physical system by writing the independent set of system equation, and then we can draw the signal flow graph from the equations also. So before that, we need to find out some terminologies of the signal flow graph. So these are an example of the signal flow graph. Here there are four nodes, x1, x2, x3 and x4. So first we need to consider what is a node. Now node, a system variable which is equal to sum of all incoming signals at the node, and outgoing signals from the node do not affect the value of the node variable. So, and there are different type of nodes. First is the input node. An input node only has the outgoing branches. Here in this example, only x1 node have the outgoing branches, but for the x2, x3 and x4 all have the incoming nodes. So x1 is the input node of the signal flow graph, whereas the output node has only the incoming branches. That means here x4 is the incoming branches only. So this is considered as the output node or the sink. And this x2 and x3, which have both the incoming and outgoing branches, can be denoted as a mixed node. Next is a branch. A branch is actually a directed line between the nodes. So in between x1 and x2, the direction is given in this direction from left to right. So this line is a branch. And what is a path? Path means unidirectional succession of branch along which no node is crossed more than once. So here we can say that x1 to x2 to x4 is a node, is a path, or x2 to x3 is a path, or x2 to x3 to x4 is a path. And the forward path means from the input node or the source to the output node. This is the only two possible combinations are there. Here one is from x1 to x2 to x3 to x4. So this one is a forward path, and another one is x1 to x2 and directly x4. So these two are the forward paths which will start from the input node and terminate at the output node. Next is the feedback loop or feedback path. Now a loop which starts from a particular node and ends at the same node without crossing the same node by more than once. So if you consider this one, so it can be started from x2 node, then goes to x3 and then returning back to the x2 node. So this can be considered as a feedback path. So x2 to x3 and back to x2 is a feedback path. Another one is self loop. Self loop means it consists a single branch, and it also starts from a node and ends at the same node having only one branch. And in this case, this A33 is a self loop because it has only one branch and it has been started from x3 and finally terminated at x3. Next is the path gain, and path gain is the product of all branch gains in a path. So first consider the first forward path, that is x1 to x2, then x2 to x3, then x3 to x4. The transmittance is from x1 to x2 is a to 1. The transmittance is the gain between nodes or branch gain, and it also represents in terms of the transfer function. So a to 1 into the path gain of this, that is a32 into a43. So combination of this a21 into a32 into a43 is the path gain. And the loop gain is the product of the branch gain of the loop, that is a32 into a23. This is the loop gain. Next is the non-touching loop. If it is possible that there are two loops which have no common path or no common nodes within those two loops, that are known as the non-touching loop. So here the self loop and this loop both are sharing this common node x3, so there is no non-touching loop in this example. Next is construction of signal flow graph. Now signal flow graphs can be constructed from the linear equation. So linear equation combinations are given here, and there are 6 equations. So from these equations we can say there will be 6 nodes, whereas the x1 node has no incoming branch. So the incoming branch means the incoming will be denoted at the left hand side. This equation means in x2 the incoming branches are x1 and x5, and here there is no incoming branch at x1 node, so x1 can be taken as a source node, and for the x6 there is no outgoing node from x6, so x6 can be considered as the output node, and in between nodes are x2, x3, x4 and x5. So if we consider the first equation, that is x2 equal to x1 plus a into x5, that means input at the x2 nodes are from x1 the coefficient 1 gain is coming, that is 1 is written here, and from x5 a is coming. So from x5 node the gain a is coming to the x2 node. Similar can be applicable for the next node, that is for x3 b coefficient is coming from x2. So from x2 the signal is b, and for x4 the coefficient is e. And for the x4, that is b into x2 plus e into x3. So for the x4 node, the b into x2 plus e into x3. So for x5, that is f into x4, from x2 this is f plus g into x3, and for x6 that is equal to x5. So this coefficient is 1. In this way, we can construct the signal flow graph from the linear equations. And next is the signal flow graph from the block diagram. To construct the signal flow graph from the block diagram, we have to take care of 2 points. First, all variables, summing points and takeoff points will be replaced by the nodes. And if a summing point is placed before the node, then placed before the takeoff point, then represent the both by a single node in the direction of the signal flow. And if a summing point is placed after the takeoff point in the direction of the signal flow, then represent the both by separate nodes. So let's take an example. Here one block diagram is given. We need to construct the signal flow graph from this block diagram. So here this summing point, and there are 2 summing points, 1 and 2, and there are 2 takeoff points. So this summing point is placed before this takeoff point, hence So both are represented by a single node. That means this node 1 is representing both this coming point as well as this takeoff point. And here also the coming point is placed before the takeoff point. And so this second node represents this coming point as well as this takeoff point. Now in this coming point 1, the RS is incoming. So in node 1, RS is incoming, and from 2, CS is outgoing. So from 2, CS is outgoing. In between 1 and 2, in the direction of the flow, there are two transmitters, one is G1 and G2. So in between 1 and 2, in the direction of flow, the transmitters are G1 and G2. Whereas in feedback, that is in the opposite direction flow, H1 is present. So here it is H1, and due to this minus sign in this coming point, that is H1 is used as a negative feedback, we need to put the minus sign over here. So this is the complete signal flow graph from the block diagram. Next is the Mason's gain formula. Now the Mason's gain formula is used to find out the transfer function from the signal flow graph, and it is used for determination the overall transfer function gain. And this is very convenient and easy way to finding the relation between the input and output variables from the signal flow graph. And the overall transfer function Cs by Rs is given as summation of Pk delta K by delta, whereas the K is the number of the forward path and Pk is the kth forward path gain, whereas delta is calculated as like this 1 minus summation of all individual loop gains plus summation of all possible gain products of two non-touching loop gains minus summation of non-touching all possible combination of three non-touching loop gains, and so on. So from this equation we can say that first we need to find out individual loops, then the two non-touching loops if that are possible, and if it exists then we need to find out the three non-touching loops, and so on. And finally the delta K, and delta K is the 1 minus the part of the loop which is not touching the forward path. So for first, if there are two number of forward paths, then we need to calculate the delta 1 and delta 2. If the number of forward path is 4, then delta 1, delta 2, delta 3, delta 4 like this. So let us take an example. We need to find out the transfer function of this signal flow graph using the Mason's gain formula. So here in the signal flow graph, first we need to identify how many forward paths are present. So here there are two forward paths. One is from R to C. This path is nothing is written over here. That means we need to consider 1. So 1 into G1 into 1, that is G1, and second forward path is 1 into G2 into 1, that is G2. So there are two forward paths, G1 and G2. Next we have to identify the loop. So there are two loops, one is G1 into minus H1 and another is G2 into minus H1. And there is no two non-touching loops because both the loops is sharing the node 1 and node 2 as well as the common branch as minus of H1. So next we need to calculate the delta 1, and delta 1 means there is no loop is present which is not touching the first forward path because both the loops are touching the first forward path on G1. And as well as same is applicable for delta 2, and both delta 1 and delta 2 is equal to 1. Next I need to calculate the delta, and delta is 1 minus summation of individual loop gains. So there are two individual loops, one is G1 into minus H1, another is G2 into minus H1. So 1 minus summation of these two gives the delta. Next we need to apply the transfer function is equal to Mason's gain formula P1 delta 1 plus P2 delta 2 by delta. So P1 is the first forward path into delta 1 is 1, and P2 is the second forward path into delta 2 is the again 1 over here, and delta equal to 1 minus summation of individual loop gain, that is equal to 1 plus G1 H1 plus G2 H1. So this is the overall transfer function of this signal flow graph. Let's consider another example. So here you can see that there are two forward paths. One is from 1 into G1 into G2 into G4 into G5 into 1, and another one is G1, G2 and G3. Next, we need to identify the loop. So let us consider the loop. First, G4 into G5 into minus of H2, then G3 into minus of H2. Another loop is G2, G4, G5 into minus of H1, then G2 into G3 into minus of H1. Another two loops are there, that is G1, G2, G4, G5 into minus 1. Another one is G1, G2, G3 into minus 1. So there are total 6 individual loops at present. And here also all the loops are sharing the node 6. So there is no two non-touching loops. Next we need to calculate the delta 1 and delta 2. So for delta 1, all the loops are connecting with this fast forward path G1, G2, G3 and G5. So delta 1 is equal to 1, and as well as all the individual loops are connecting with the second path, that is G1, G2 and G3 by this node 6. So there is delta 2 equal to also 1. Next we need to find out the delta, that is 1 minus summation of individual loop gains, and finally we are applying the Mason's gain formula P1 delta 1 plus P2 delta 2 by delta, and this gives the overall transfer function like this. Let's take another example, and here the forward path gain is 1 into G1, G2, G3, G4 into 1, and another is G1 into G5. Next is the individual loop. Here we can consider the individual loop as the self loop also considered. So this is loop 1, that is G1 into minus of H1. Next is G3 into minus H2, another loop. And other loop is G1 into G2 into G3 into minus of H3, and finally the self loop minus of H4. So there are total 4 numbers of individual loops, L1, L2, L3 and this is L4. Next we need to find out, is there any two non-touching loops. Two non-touching loops means in between those two loops there will be no common path or no common node. So if we consider this L1 into L4, because in this equation, in this formula, we need to find out the possible gain product of the two non-touching loops. So here the L1 and L4 is not sharing any node or any branch. So L1 and L4 may be non-touching loops. Another is L2 and L4, both are do not share any node or common path. So L2 into L4 is another non-touching loop. Next is L3 and L4, and finally L1 and L2. So all these 4 combinations are two non-touching loops. That is L1, L4, L2, L4, L1, L2 and L3, L4. Next we need to find out, is there any possible 3 non-touching loops. So if we consider this L1, L2 and L4, so among these 3 there is no common node or common path. So these 3 can be taken as the 3 non-touching loops. Next we need to find out the delta 1 and delta 2. So for delta 1, there is no loop is present which is not touching the first forward path G1, G2, G3, G4. So delta 1 is equal to 1. But in case of delta 2, the loop L2, that is G3 into H2 minus of H2, is not connecting the path G1, G5. So the delta 2 is 1 plus G3 into H2. This plus becomes the actually it is 1 minus of the loop gain, that is minus of G3 H2. So it becomes 1 plus G3 into H2. Next we have to identify the delta, that is 1 minus summation of individual loop gain plus all possible gain products of 2 non-touching loops minus 3 non-touching loops. And there are no 4 non-touching loops present. So we can complete the transfer function by using the Mason's gain formula P1 delta 1 plus P2 delta 2 by delta. By putting the values, we can calculate the overall transfer function of this given signal flow graph. And these are my references. And in this video, we have completed the signal flow graph construction from equations, from the block diagram reduction technique, and from using the Mason's gain formula, we can find out the transfer function of the signal flow graph. Thank you.